Okay, let's just dive right in, because something absolutely remarkable is happening in the world of science right now. We're going to explore this growing pile of evidence that suggests our fundamental understanding of the universe, well, it might just be incomplete. And look, that isn't some fringe idea from the sidelines. This is a possibility that top cosmologists are facing head on, all based on data from our most powerful telescopes. It's a statement that kind of sends a shiver down your spine, right? But here's the twist. Because in science, this is where the magic really happens. This isn't a disaster. This is the moment right before a massive breakthrough, a potential revolution in how we see, well, everything. So let's get into why scientists are so thrilled that our cosmos seems to be misbehaving. To really get why this is such a big deal, we first have to appreciate the theory that has served us so well for so long. You can think of it like the peaceful, orderly town in a detective story, right before the first mysterious clue turns up. This standard model of cosmology, our rulebook for how the universe works, was beautiful. It told this one cohesive story all the way from the Big Bang. It explained what the universe is made of, how it should evolve, and it matched our observations so well, it really felt like we were closing in on the ultimate cosmic code. But then, the universe started acting strange. The story wasn't quite adding up anymore. And these weren't just small details we're talking about. They were fundamental plot holes that began to appear in our neat cosmic narrative. At first, it was pretty easy to just dismiss them as statistical noise, tiny little errors that would surely disappear once we got more precise data. But the exact opposite happened. As our instruments got sharper, the errors didn't shrink. Nope, they got bigger. The cracks started to spread. And this leads to a really crucial question that scientists are asking themselves right now. To understand what they mean by this, we need a quick trip back in scientific history. It's a brilliant way to frame the two possible outcomes of this whole mystery. So this slide breaks down our two options perfectly. On one hand, are we in a Uranus situation? That's where our theory is basically right, but we're just missing a piece of the puzzle, like when they realized the hidden planet Neptune was tugging on Uranus. Or are we in a Mercury moment, where the rulebook itself is just plain wrong, and we need a revolutionary new idea, like Einstein's general relativity? That's the million-dollar question. So to figure that out, we have to look at the evidence. Like cosmic detectives, cosmologists have been gathering all these clues that just don't fit the official story. And there are three really big ones we need to dig into. The first clue, and this is a big one, challenges one of the most fundamental ideas we have, that on the very largest scales, the universe should be pretty much the same everywhere you look. Smooth, uniform. Turns out, that might not be true at all. I mean, the scale of these things is just staggering. We're finding arcs of galaxies that are billions of light years wide. Our models say that matter should be spread out evenly on these scales, but instead we're finding these colossal structures that are just too big to exist. It's like finding a mountain range on a planet that was supposed to be perfectly smooth. And this analogy just illustrates the problem so well. If these giant structures are real, it means our little patch of the universe might not be representative of the whole thing. We could be sitting on a cosmic cherry and mistakenly believing the entire cake is made of cherry. This would shake the very foundations of how we study the cosmos. All right, let's move on to our second clue, which is a direct and really stubborn contradiction. For years, we've been trying to nail down exactly how fast the universe is expanding. The problem is, we keep getting two different answers depending on how we look. So here's the deal. When we measure the expansion rate based on the early universe, like its baby pictures, we get one number. But when we measure it using objects in the nearby or late universe, we get a different, faster number. And both of these methods are incredibly precise. Yeah, and this is not a small discrepancy we're talking about. The chance of this being some random statistical fluke is now less than 1 in a million. The universe is telling us two different things at the exact same time. Something fundamental is either missing from our equations, or it's just broken. Our third clue is the most recent, and it comes to us from the incredible James Webb Space Telescope. I mean, almost as soon as it opened its golden eyes, it started finding things in the early universe that simply should not be there. This timeline really shows just how startling this discovery is. Our models predicted it would take a whole lot longer for galaxies to grow this big and this complex. But Webb is finding them fully formed just a couple 100 million years after the Big Bang. And I just love this quote because it perfectly captures the surprise and the confusion here.
these galaxies are just too mature, too quickly. It means either galaxy formation is wildly faster than we ever thought, or the timeline of the early universe itself needs a major rewrite.
Now look, any one of these clues on its own would be a fascinating puzzle, right? But when you start to put them all together, along with a bunch of other lingering issues, you start to see a pattern. You see a theory that is genuinely under strain.
And it's not just those three big clues. There are all these other nagging problems. For instance, dark matter, the invisible stuff that holds galaxies together, it isn't behaving exactly as we expect. And there are these weird hints that dark energy, the force pushing the universe apart, might be changing over time. The list of anomalies is just growing, putting pressure on our standard model from all sides.
So, I know, it sounds like a total mess, right? A broken theory, a confusing universe. But this is the most exciting part. Because in the history of science, a crisis is never the end of the story. It's the beginning of a brand new one. And this right here is the key takeaway. A scientific crisis is a sign of progress. It's the universe knocking on our door, telling us that there's something more profound, more beautiful, and way more interesting waiting to be discovered, just beyond what we currently understand. All of these cracks and these clues and these contradictions, they are not failures of science. They're invitations. They are signposts pointing us toward a deeper reality. And it doesn't matter if it's a Uranus moment where we find a missing piece or a Mercury moment where we have to rewrite the rules completely. Either way, we win. And so we're left with this incredible, tantalizing question. The cosmos is speaking, and our job now is to learn how to listen. The one thing we know for sure is that the story of the universe is about to get a whole lot more interesting.